Hi everyone, and welcome to our unit on medical geography. We're going to be studying this from the perspective of people, plants, and animals, and looking at some things that are unique to each one of those groups, as well as some of those things that are the same between those particular groups. We'll have several different parts that you can watch at your leisure, all together or separately, pausing as needed to take notes or going back to review the information. And as always, don't hesitate to reach out to me with questions if you're not sure about some of the information that we're covering. So there are a few questions I'd like you to consider as listed here on the screen. There are 4 of them. We want to think about what kind of impact diseases have on our health, and not just our health for people, but also plants and animals and other species. We can think about the impact on gender. We can think about the role that environment plays in it, but also we want to think about why diseases are geographic, what makes them so. And we will look at some examples in a few slides. Typically in class, one of the things I have you do is answer some questions and then share your answers or discuss those questions and answers with neighbors sitting by you. Of course, we can't do that in this venue, but here are some questions that I would probably be asking you if we were meeting face to face. So you may want to take a moment and just pause it for a couple seconds and read through those questions and kind of think about what do you already know, what do you not know, and then when you're ready, you can move forward. So, one example, and I just realized I'm saying so an awful lot. Anyway, looking at this particular example, this map is showing us mortality for children under the age of 5. The website, which is listed down at the bottom of the screen, is an interactive website, so you could go to it and you could pick different types of phenomena that you might want to look at. But one of the things I want us to continue to do throughout the semester is focus on distributions and looking at patterns and coming up with inferences for why we have the patterns that we do. So hopefully as you're looking at this map, one of the things that jumps out to you is that big circle that just showed up around Africa where there are really high mortality rates. And then we can look at what we have adjacent to that area where we have the really high mortality rates, where things are outliers, particularly high or particularly low, and think about why do we see what we see where we do, right? Our 3 questions: what is it, where is it, why is it there? So we can look at it from this perspective too. All right, these are just some examples that we're looking at. This is an area deprivation index that was put together for Alabama. This is a program that the University of Wisconsin did. They put together an atlas. You can see the website at the bottom of the page. And one of the things is they looked at disadvantaged neighborhoods. So they had criteria to define a neighborhood as disadvantaged or not disadvantaged, and they had a various scale for that as well. And then they looked at what kind of health outcome you could expect to have in that particular neighborhood. So if your neighborhood was considered to be highly disadvantaged, so an area of deprivation, on the map that shows up to be these dark oranges and these reds. So you can see where we have those scattered around within the state of Alabama. We could look at a map of Wisconsin and it would give us a different type of pattern, but it would still have the same scale. We can also look to see where do we have neighborhoods where we have less disadvantage and where your health outcomes are likely to be better. So why do we have the northern half having less disadvantage, the southern half having more disadvantage? Those are social reasons, and we can think about that also at a more finite scale. So if we zoomed in on one of those urban centers on the map, we can see that our data here, which I believe is in census blocks rather than census tracts, is showing us that we can have some areas of low disadvantage right next to areas of high disadvantage. So again, looking at those spatial relationships as well as the social environmental components as well. And we can think about environmental justice issues and public health issues and how policy comes into play or doesn't come into play to affect the populations that live within that particular urban area, as we can see here. Now we also want to think about diseases and their impact on plants and animals. So here's an example for one of our 4-legged friends, dogs. So heartworm disease. So if we're thinking about diseases in regards to medical geography, and we'll define a disease in the next couple presentations, part 2 or part 3, can't remember right off the top of my head. But if we're looking at heartworm disease, this is how it would infect a dog, right? You have a mosquito that bites the dog, and then it has larvae that gets into the dog's system where it matures and creates these microfilariae in the blood, how long it takes for that to happen, what happens when a mosquito ingests that as it bites the dog, and then it takes that, gives it to another dog, etc., etc. So something we have to be aware of. But we want to think about, well, what dog species are impacted? What kind of mitigation efforts do we have? And what kind of rates do we see at a national scale? When we look at the rates on a national scale, we can map it, right? And so veterinarian offices can report this information to the Heartworm Society, and then they can plot it and they can make a map. So this is showing us what it looked like in 2004. So you can see what kind of distribution there was in regards to the number of cases, what areas we had larger numbers, what areas we had lower numbers. And then we can key in, for example, into the lower Mississippi River Valley, where you can see that there are over 100 plus cases per clinic that show up in 2004. Jump forward in time to 2016, right? And we look at that same area where the yellow arrow is pointing for us, we can see that it's moved further north up that Mississippi River Valley. The cases down in Louisiana have lessened a bit, but we've had it go further up towards Illinois. We've had it increase the number of cases as we move along the Gulf Coast into Texas, right? And so why do we see the changes that we do? Some of it is going to talk about reporting, right? Some of it might be the number of pets that people have 12 years later from 2004 to 2016. It might be different depending on species. So all of those are questions that we would want to explore, particularly if we were an epidemiologist, whether we're an epidemiologist for people or whether we're one for animals. And we could also look at another example. So here's chronic wasting disease, and we know that that's very prevalent in Wisconsin. So one of the things that we do when we look at epidemics is we look at regional clusters. So where do we have an outbreak? And we'll define some of our terms in another forward-coming presentation. But where do those outbreaks occur, right? And do they stay in a particular location or not? So the map that we've got with the USGS here is giving us free-ranging populations, and something with along the lines of distribution prior to 2000. And this map was updated in March 2020. It tells us whether the disease was occurring in captive facilities or not, whether it occurred in the past, in the future, etc. So all that's on the key. But we can see what the animal looks like as it's impacted by chronic wasting disease. Very skeletal. The fur changes as well. It gets very mottled, and its coverage, it becomes very poor as well. But we want to think about, why do we have a cluster around Wisconsin and Illinois and parts of Iowa? Why do we have this cluster out here in Pennsylvania? Why do we have the cluster up in Canada? Why do we have this cluster out in the West? Right? So how did that disease go from one location to another location? Where did it start? What its source area? How does it diffuse? Those are questions that we ask regardless of what the disease is and regardless of what the ecosystem is. And another thing we can think about from the plant and animal kingdoms are plants. So some of you might have heard of the emerald ash borer. So we've got a picture of ash trees up in the top left-hand side of our screen. On the top right, you can see the city of Roseville, Minnesota has put this tag around an ash tree, talking about the borer killing it. And if you haven't seen what one looks like, there's a couple pictures down in the lower left corner. You get an idea about their relative size. Of course, their name is associated with their color. They're quite colorful little beetle. And they have holes, so you can see the picture with the penny. There are some holes, and if you found one, you could look in there and say, oh, where is the little beetle? But the real killer is not the beetle so much, it's when it's in the larvae form, which is what you see in the picture on the lower right-hand side. And the larvae hatch from those eggs that the beetles lay underneath the bark, and it makes those really twisty, curly types of patterns that you see in that right-hand image. So we can see what the beetle looks like and what the larvae looks like and what the impact is on the tree, but where are the trees, right? And what kind of risks do forests and ecosystems have? So as we're looking at this map, you can see where there's high risk, you can see where you have moderate, you can see where you have low risk. And the question I'm going to leave you with and not answer is, why do we not see those same risk assessments as we move west of the Missouri River? Why do we not see them in the Rocky Mountains and the intermontane west? And why do we not see them to the same extent in the southwest as well? Why do we see low to moderate risk in Arizona? So we want to always connect all of these ideas into the geographic perspective. So two things we want to keep in mind from the geographic perspective are diffusion and mobility, right? Diffusion, we have a core area, we have a source and an idea, a technology diffuses outward from that location. And there's a couple different ways that it can happen. We also want to think about mobility, and we want to think about the mobility of people, but we also want to think about the mobility of species, particularly when we're looking at migration. And for migration, all you have to do is think about birds. Various bird species migrate on a yearly basis. They go from north to south or south to north, depending upon the season and depending upon what hemisphere they find themselves in. And as they're migrating, what is it that they are taking with them from point A to point B relative to disease, and what kind of an impact could that have on a particular population? The other things we want to consider here are the health and the demographics of a population, transportation of that disease and how it occurs, what kind of policies we have socially for our human health, but also what kind of policies do we have environmentally that can protect plants and animals. And we want to think about that environmental impact, because we need to remember that we are socially embedded into a physical, natural environment, and that what we do is going to impact that environment, and also what happens in that environment is going to impact our social systems as well. So we end part one after about 12 and a half minutes. When you're ready, go on to view part two.